Good morning, class. So far, we have discussed the basics of the subject, followed by the computation and computing machine. Then we discussed the automata or what is automaton, followed by finite automata. Then we have discussed the representation of deterministic finite automaton. We have discussed that the DFA can be represented either in two ways, either as a mathematical representation, or we can have the DFA in form of state transition diagram. In this lecture, we'll discuss how a given automata process the input string. Fine. So let's move to the next slide. But before discussing the mechanism how this string is processed by the given automaton, we will discuss what is an input string. Basically, what is the input string? So we'll discuss the basic terminology involved in the definition of input string. We already have discussed that the sigma is known as input alphabet. So what is input alphabet? Input alphabet is a set of characters or set of elements which are taken by the automaton as an input. So the automaton can take either 0 or 1, not other elements as an input. Fine. So if input alphabet sigma is given as 0 or 1, then summation square, this is another set of all strings. Remember, all strings of any length. So the length of string could be 0, 1, 2, 3, 4. So of any length including the empty string, as I mentioned here, of any length. So the length could be 0. So the string of 0 length also included in sigma star. So what is sigma star? Sigma star is a set of all strings of any length. So therefore sigma star will be the string of 0 length, which is represented by epsilon. So epsilon is used to represent empty strings or strings of 0 length. Then the string of length 1 will be 0. These are the strings which are made up of this input alphabet. So this is the next string, this is the another string. In this string we have only one character. In this string also we have only one character. This is made up of 0, this is made up of 1. Then we can have the combination of these two elements. Like first combination is 0 0, this is another string, 0 1, 1 0, 1 1. Then these are the strings of the length 3. So I am repeating this. This is the string of length 0. These two are strings of length 1. Now these 4, 1 2 3 4, these are the strings of length 2. Then we will have the strings of length 3. Then we will have the strings of length 4, and so on. So this is the infinite set. So therefore sigma star is strings of all length starting from 0 length to the n number of length. Whereas if sigma is given as 0 1, then sigma plus is set of all strings of any length excluding the empty string. So here the 0 length string is exempted. So of any length excluding the empty string. So 1, the smallest string will be of the length 1, and so on. So these two will be used in the future definitions. So the next is length of the string. So length of the string is nothing but the characters in the strings, number of characters in the string. So if W is a string, set of characters, string is nothing but a set of characters. So which characters? So the characters given in the input alphabet. So what is a string? A string is a combination of characters of input alphabet. You will not have extra characters. Fine. So you cannot have 2 3 4 5 here, because input alphabet is having only two characters, either 0 or 1. So if W is a string, then W inside these two pipe symbols is called as length of it. So this is used to denote the length of it. For example, if sigma star is given as this is a finite set, only selected strings are used here, and W belongs to sigma star. It implies that W is one of the string given here. Right. So if W is epsilon, then its length is 0. If W is 1, then its length is 1, because only one character is here. If W is 1 again 0, then its length is 1. If W is 1, then its length is 1. This is the string of length 2, and all these 4 is having the length 2. So length is denoted by these pipe symbols. Now coming to the processing of input string, let the string given is x, y, z. So this is, for example, we have 3 characters in this string, and those are x, y, z. So this is a single string. Then the string will be processed by the automaton as given below. So this is a generalized formula which will be used to discuss or describe the how these strings will be processed. So this is a transition function. This is the current state, which will be the initial state, and this is the input string. So if it is given, then this is equal to delta and delta again. So this delta is extended, that is applied inside. So this q and this first input character, so current state and the first input character. So delta is extended to the current state and first input character, and then yz is left here. Fine. So this will be better understood with the help of a example. So the transition will continue. This transition will continue till all characters from input strings are processed. Let's take it by one example. Let the input string is W equal to 0 0 1 0. So in place of XYZ, now we are taking 0 0 1 0, and this is the automaton given. So automata must be given, otherwise you cannot have the transition functions. So without having the automata or without having the transition table, one cannot apply this transition. So then the string will be processed iteratively as. So what you have to do, you have to apply the transition function, then you will write the initial state here. So what is the initial state here? S1 is the initial state. Why? Because this is marked by the arrow. So initial state and then the string given. Okay, so what you have to do now, you have to extend the transition function. How it will be extended? When the transition function will be applied on the state given and the first input character. So what is first input character here is 0. So what we are doing, we are applying the transition on current state and the first input, which is 0. So the rest of the input string is left here. So delta S1 0. So this is what is the state after transition. Its output will be state after transition when input 0 is consumed by or applied on the state S1. So S1 on input 0, so it is going to S2. Fine. So that's why this transition, which is written in blue, when this is applied, it will be replaced by S2. Why it is S2? Because the current state S1 on using input 0 is going to S2. That's why S2. So now you have this transition and one input string is consumed. So this transition function is written here, and now you have to, your current state is 0 and the first input character is 0 again, so this one. So now you have to extend the transition on S2. So when this transition function is applied on S2 on input 0, S2 on input 0 is going to S1. So output of this transition will be S1. So S1 is replacing this transition function. So now you have to extend it again. It is written here, this is written here, S1 on 1. So transition S1 on 1. S1 on 1 is going to S1 itself. So that's why you will have the S1 here. I am repeating, when this transition function is extended, it will be written in this way: delta S1 on input 1. Fine, now 0 is left here. So S1 on 1 is S1 itself. S1 on 1 is S1 itself. So where from you find S1 on 1? From this transition state transition diagram. And this is the last, because the last input is left here. So you will apply the transition function on S1 and 0. So transition function S1 on 0, it is going to S2. Now because all input strings or all input characters are consumed from this string, this is your final answer. So in this way, one by one, all characters of these strings are processed. I am repeating, in this way, by extending the transition functions on the input characters one by one, the string is processed. Fine, this is the only way. So what is here, what is the meaning of this one? So when you apply a transition function and the current state and the multiple characters are given, you will extend the transition functions on these characters one by one. That is, first it is applied on the first character, then you will have a state again here, its output will be a state, then you will extend the transition function on the second character, then you will have the state again here, and then you will apply the transition function on the last character. So these characters of the input strings are processed one by one. Let's take it by one more example. In this example, the automaton is given and the input string at this time is ABA. What is input alphabet here? In this case, the input alphabet is A comma B. So input alphabet can be any character, but whatever is written here, that could be the only input of this automaton. So if A and B is written here, you cannot have C as an input, you cannot have D as an input, only you can have either A or you can have B or you can have any string which is made up of A and B. Okay, so what is the input string given here is W equal to ABA, only 3 characters are here. So you will apply the transition function delta on Q0. Why Q0 at this time? In the previous question it was S1, but now we are taking Q0 here. Why Q0? Because Q0 is initial state. How initial state is identified? By this arrow. The arrow which is coming from nowhere, from no state, this is the starting state. So starting state Q0 and the first input character. So we will extend the transition function. We will take Q0 and the first input character. What is the output of this transition? The output of this transition is Q0 on input A. So look at this diagram, Q0 on input A, it is going to Q1. So that's why Q1 here. Now we are taking this transition function, we are rewriting this transition function here, and we will take the first character which is left here, that is a B. So extending this transition function delta Q1B. So what will be the output of this transition? Q1 on input B. Q1, this is the state Q1 on input B. So A and B both are written here, that is either on A or on B, it is moving to the self. So if input is A, it will move to the Q1. If input is B, then also it will move to the Q1. That's why Q1 here. So now let's take this transition, and then because there is only one input left, then we will not extend it. So delta on Q1 comma A, Q1 comma A, that is the Q1 also, because all input characters are consumed or processed. That's why this is your final answer. So this is the way, or in this way, the input string will be processed. So what is input string? Input string is nothing but set of characters from the input alphabet. So any collection of characters from input alphabet, that is called as input string. Okay, or we can say that input string is any string, any element which belongs to sigma star. So any element of it is known as input strings. Okay. Now these are the assignment questions for you. What you have to do, you have to process the input string W for the given automaton M. So you have two questions. In the first question, the input string given is 0101 and the automata given is this one. So how you will process? In this way. You will proceed and you will find out this will be your answer. Fine. And the second question is input string is given but the automaton is this one. So what you have to do, you have to solve these two questions by the name assignment number 2